Welcome to this webinar. Before we begin the presentation, I want to provide you with a few housekeeping items. On your screen, you will see a taskbar with icons. Each icon is assigned to a particular element of today's webinar. Click on the person icon to learn more about today's speakers. Throughout the presentation, you can network with others or submit questions to the speakers in the Q&A and chat box next to the slides. Download resources from the cloud icon. After the webinar is over, please take our survey to tell us how we did. Today's event is being recorded and archived and will be available within 24 hours. For on-demand questions or comments, send us an email by clicking Need Help? Email us. If you experience any technical issues today, please refresh your browser by hitting F5 for PC or Command R for Mac. And now I'm excited to turn it over to today's moderator.
Good afternoon and welcome to this webinar. Prepare for the trend of flammable refrigerants in commercial refrigeration. This event, brought to you by the ACHR News, is sponsored by Embraco Nedic. I'm your moderator, Kyle Ruggiero, Editorial Director of the News. Thanks for joining us today. Today's presenter is Matthew Sopp. Matt is a key account manager with Nedic Global Appliance and represents the distribution and aftermarket segment for the Embraco brand in North America. Previously, Matt was a nuclear mechanic in the U.S. Navy for 9 years and served on the USS Augusta SSN 710. He has worked as a mechanical maintenance planner at the Braidwood Nuclear Generating Station, where he created work packages for preventative and corrective maintenance, as well as major engineering changes and projects. He also performed root cause evaluations and audits to analyze human performance, equipment failures, and evaluate for process improvements. As a technical specialist at Embraco, Matt worked on training and technical support for HVACR contractors and technicians. As a sales engineer with Trane, he assisted with the design of HVAC system solutions for industrial and commercial customers. Don't forget to submit your questions, and later in this program, Matt will address as many as possible. Today's event is being recorded and archived at achrnews.com/webinars. And now I'm excited to turn over today's presentation to our presenter, Matt Sopp. Please take it away, Matt.
Thanks, Kyle. And thank you to everyone who is taking the time to join us this afternoon for a little R290 and R600A training. I'm going to go ahead and get started here. So, natural refrigerants, as I said, R290 propane and R600A isobutane. Those would be the focus of the training presentation today. Specifically, R290 is the one we'll really focus on, as that's the one that's primarily used for commercial refrigeration. But we will see some references to R600A as we go through the presentation. And that one's out there. You'll see it from time to time, and but it's much more used for domestic and household applications. So what we're going to hit today, right in the middle of the screen, is really the big one, the safety and practical applications of working with R290 and R600A, any of these natural refrigerants, probably the most important piece. But we'll also touch on some of the legislation that's out there, why the OEMs and manufacturers like Nedic and Embraco decided to go towards natural refrigerants. And we'll look at some of the compressor changes, some of the things that are different, some of the things that are the same about these systems. And then, as I mentioned before, the most important thing, how to be safe when working on these systems. So for the new legislation, when you look at this slide, maybe one of the most important things that has caused a lot of confusion when it comes to the refrigerant landscape and commercial refrigeration is the fact that it says California Air Resources Board on the left side of your screen. A few years ago when I started working on this presentation, it used to say EPA SNAP, and the EPA was going to look at banning some of these gases that we see listed here in front of us, R134, 407s, 404A, 507 for commercial refrigeration. And they were going to step that out over a period of a few years in different equipment in that stepped out time period. And they ended up being taken to court and by some of the refrigerant manufacturers. And the refrigerant manufacturers won, but it wasn't so much that the courts were telling the EPA that they didn't want them looking out for the environment. It's that what they were trying to say is procedurally how they were going about the ban was incorrect. And So even though the EPA got stopped by the court system, at that point, some of the states stepped forward. And so we now have California Air Resources Board written on this slide, just as an example. But California, Washington, New York, New Jersey, Vermont, several states like this have gone ahead and implemented a lot of those same bans and the same changes. And there's about 15 to 20 other states out there that are currently working on their own legislation, trying to move forward with these changes and these bans when it comes to certain refrigerants. And so this was one of the big pushes that really got the manufacturers looking at new refrigerants, what we were going to use for our next generation of equipment. Next up, we've got a quick poll question before we get into all of the legislation specifics. So here we go with the poll question. Have you worked with flammable refrigerants before? And we've got a few answers there. I have never seen a system that operates with flammable fluids. I've seen a system but never worked. I've seen it a few times, done it several times. Please give us an answer here. And it looks like as it comes in that more people are less familiar with these gases than are more familiar with these gases. So a good day for safety training. All right, it looks like it's starting to slow down a little bit here, so I'm going to go ahead and click forward. And it looks like primarily you can see the top two there. I have never seen a system that operates with flammable fluids, and I've seen it, but never worked on it, are our big two answers. So, as we move forward here, just to kind of get everyone into what you're about to see on the next couple screens, we'll look at the safety classification for these refrigerants. What we're used to seeing out there, your R22s and R12s, R134A, R44A, all these gases, and when you'll see them here in a couple slides, they fall into this A1 category, so low toxicity and no flame propagation. And what we're looking at today, R290 propane, R600A isobutane, they fall into this A3 category, so still low toxicity, but now we have a high flammability. Just for a reference as well, you'll also see at least one or two refrigerants on the next couple slides that have an A2L category or classification. And you don't see an A2L on the screen, but what A2L is we've started to make a lot of new refrigerants for these changes, trying to get the global warming potential of these refrigerants down. They've created a new category that's part of this class 2 low flammability. But they might be a bit more flammable than some of the other class 2s or older class 2s. They're just not highly flammable like with the A3 gases, like a propane or an isobutane. And then, of course, you see the class B high toxicity over here, and that might be something like a R123 or ammonia, if you're familiar with those refrigerants. And you can see here on this next slide, the A1 classification for those refrigerants that we're used to working with. And then, of course, the A3 for R600A and R290. So we'll start by taking a look at California. And so on the left side of the screen, in that first block, you can see the banned substance. And you can see R134A and R404A both listed over there. And so the GWP, what we're looking at there, is the global warming potential. And you can see the value of R134A is 1,430, R404A 3,920. And those compare to the baseline of CO2, which CO2 is what we always hear about when we're watching the news, when we're hearing about climate change. CO2, carbon dioxide, has a global warming potential value of 1. And so the easiest way to think about those numbers, what they're trying to tell us is that R134A can capture 1,430 times as much heat in the environment as CO2 could. That's kind of the basic way of looking at it. There's a lot of different numbers involved there, but trying to keep it easy, we'll just think of it that way. And so what the goal here with a lot of this legislation is to start working with refrigerants that have a much lower global warming potential as we try to combat climate change and global warming. And so in the second column, you can see the EPA final rule new equipment. In fact, it still says EPA final rule. We didn't even change that portion of the slide, it looks like. But for R134A, you can see kind of two different areas there where the global warming potentials end up. And if you look at the top two, R450A and 513A, the class is A1 still, so more like R134, R22, those traditional refrigerants, but the global warming potential is still higher, 600 and 631. When you look at the newer refrigerants, the A2L class and the A3s, the flammable refrigerants, such as R290 and R600A, you can see that now the global warming potential is much lower, in the range of 3 and 4. The same thing down here with R404. You look at a couple of the A1 replacements, R448A and 449A, and you're looking at about 1,200 and 1,300 still for the global warming potential value. When you compare that to R290, that has a value of 3 as a flammable refrigerant. So us as manufacturers and the OEMs, when you look at that, you really want to aim for something that's going to be a more permanent fix. You don't really want to hit necessarily an interim solution. And so we refer to some of these gases with higher global warming potentials as interim solutions. Great solutions for now as we try to move forward and we step away from some of the older refrigerants with very high GWPs, but also probably not the final step. It's, a more permanent solution is something like an R290 that has a GWP of 3 compared to something that still has a GWP of greater than 1,000. And so it just made more sense for the manufacturers to look in that direction as they were trying to decide how to design their next set of equipment. Off to the final block on the right-hand side of the screen, you can see the different types of systems that California started off with their bans. And so California was first. You can see a few different types of systems there, like supermarket systems and remote condensing units, where the ban was implemented January 1st of 2019. And of course, January 1st, 2020, we have a couple more that came in, standalone retail units in medium temp and low temp. And then January 1st of next year, we'll have vending machines that will also be included in these bans. And this is a ban on new equipment sales. So as we flip forward here, we'll look at Washington State. And you can see Washington State looks very similar to California. The only difference that you're going to find on this slide is if you look in the block on the right-hand side, the dates are a little bit different because Washington was slightly behind California as they were moving forward. And then as we go one more slide forward here, we'll take a look at Canada. And the left two blocks are still the same refrigerants that we're showing here. Canada just went ahead and they've included some other pieces of equipment out there like chillers, motor vehicle air conditioning, domestic refrigeration. So they went ahead and they were even more all-inclusive as to the future bans that they have planned and where they want their refrigerants to have the GWP levels for those types of equipment. So a lot of changes. The big story here maybe is for refrigerants at least, it's outside the scope of this training, which is really focusing on being safe when working with these systems. But I would definitely recommend finding a good refrigeration training class and having that be something that you continue to do over the next few years because this is just a state-by-state thing at this point. But we also have Congress who is looking at passing a bill to allow the EPA to finally make a change nationwide. But that bill has also been around since late last year, and we were hoping for the bill to be complete in 2019. And now it's May in 2020, and it still hasn't come yet. So there's still a lot of changes to be made. And so all I can recommend is that you find a good training class, a good way to stay updated and just continue to learn about the changes that are being made, what's legal in your state, what's legal in your area, what's not legal, if it can be used for new equipment or service and those kind of things, just to make sure that you're always up to date as this is changing so rapidly. One more thing that pushed the manufacturers towards looking at these refrigerants when it comes to legislation is in 2017, the DOE energy standards were updated for E-Star on the commercial appliances. And so when we look at these next couple slides, we're comparing the 2017 updates back to the 2010 standard. And so if you look at the upright glass door freezer on the right-hand side of the screen, in 2017, they were asking that piece of equipment be 57% more efficient or consume 57% less energy than it had to in the 2010 standard. And over here on the left-hand side, horizontal solid door ice cream freezers, 53% less energy consumption than in 2010. Here we have bottle coolers and professional kitchen equipment. Again, 48% and up to 50% less energy consumption than it was in 2010. So what this meant for the manufacturers was that they can no longer just look at maybe a new iteration of a compressor, an upgraded compressor that would allow them to reach a new efficiency standard. They really had to take a whole system approach and start looking at things like LED lights, CM fans and the refrigerant and the compressor and control schemes and everything involved with that entire system that's going to allow them to achieve these efficiencies. So as we'll find out in a couple screens here, R290 is also a very efficient gas, which is just one reason that manufacturers look this direction. So why natural refrigerants? Of course, as we just discussed, the very low GWP value compared to those other refrigerants that we're used to seeing, the HFOs and HCFCs and HFCs, these get down very, very low, down to a 3 on the global warming value. And they are efficient, as I just mentioned. We're looking here at a medium glass door merchandiser. This was used for this slide because it's estimated that there were about 1 million of these across the U.S. And so when we look on the left-hand side here, we have an R404A unit, and then right next to it are the numbers for an R290 unit. And this is a test that's considering LED lighting and ECM fans in there, as well as the R290 refrigerant. And they were able to take that same cabinet and go from 1,194 kilowatt hours per year and lower the usage down to 810 kilowatt hours per year. So a 32% reduction. And when you look at the impact on the U.S., 384 million kilowatt hours per year that no longer needed to be generated. From a monetary standpoint, $119 operation for the 404A unit, only $81 for the R290 unit, nationwide $38 million in reduced operating costs. And then finally down on the bottom, where the legislators were really pushing here with this CO2 and our global warming potential, about 5,000 million pounds of CO2 equivalent warming over a 10-year period. So you've removed a lot of potential for global warming by running this equipment with R290 from instead of 404. And this is also just for medium glass door merchandisers. So if we start to think about all the commercial equipment, refrigeration equipment out there that we can be changing out and using in the place of what's currently out there with the older refrigerants, you can start to see a really, really big impact nationwide. Another reason that we looked at these refrigerants is that they are safe. Luckily here in the United States, when it comes to things like this, we have a lot of regulatory bodies that these changes have to go through before we're allowed to implement. And so these hydrocarbon refrigerants or flammable refrigerants, they've been used in Europe since about 2003. We are not the guinea pigs over here. This is stuff that has been done all across the world. So the safety standards and the safety practices and ideas that we'll see as we go through this presentation are things that have been used in other parts of the world, and not just ideas and things that people have thought of to try to stay safe. This is actual practical applications and things that have been done. So, also on the left-hand side of the screen here, you can see the charge is very small. 2 to 3 cigarette lighters worth is going to be the maximum amount that you can have in one of these cabinets. Right now in the United States, the charge limit is 150 grams or 5.3 ounces. And so very, very small charge. Just to make a note, last year, the IEC, which is going to be our worldwide governing body that has a whole bunch of member countries that get together and vote on these standards, they voted on this standard and they decided to change it to make it 500 grams for the maximum charge, which is about 17.6 ounces. But that's only at the worldwide level. That still has to go through all those governing bodies here in the U.S., like the EPA and UL and ASHRAE and our fire codes and all those different kind of regulatory bodies. So we haven't seen that change yet. I just wanted to make a note that you may see a change to some larger number, somewhere between 150 grams and 500 grams in the coming years, and start to see equipment with that larger charge. Some additional benefits. You see here on the slide, looking at a discharge temperature on the right-hand side and a shell temperature on the left-hand side, anywhere from about 25 to 30 degrees cooler using R290 than using R404A or a couple of these different HFO blends. So we're expecting a longer compressor life just from less wear and tear on the compressor and on the system because of those temperatures. We've also had a reduction in refrigerant charge, which may seem obvious. We have a 5.3 ounce maximum for our charge. But if you look here, R290 is going to be on the right-hand side and then the far left-hand side. And so when you compare to R404A and R134A, you're looking at about a 45 to 50% reduction in the charge. In the middle is R600A, and you're looking at about a 35 to 40% reduction in the charge compared to R134A. So in the end, this could end up with a good cost benefit when it comes to using these refrigerants. Just to give you an idea, when I started working on this presentation and traveling around a few years ago, the little 14 to 16 ounce canisters of R290 that you see in the wholesalers, I would typically see those for about $250 each. As I travel around now and do this presentation, I typically see them anywhere from $18 to $40 to $50, depending on what region I'm in. So they've come down that much in just a couple years' time, and as more of this equipment starts to get outside of its manufacturer's warranty, and it becomes typical for us to be working on it in the aftermarket, and as the supply goes up, you'll likely continue to see that cost go down. Okay, we've got the next polling question here. Do you think OEMs should migrate to natural refrigerants, A3, or alternative refrigerants, the A2Ls? Pretty easy one here. We've only got two answers. We have the go natural or the alternatives. I'm just starting to see some numbers come in here, so I'll wait for a few more seconds. Okay, so it looks like a pretty hefty majority is thinking go natural with the A3s, which is what we're primarily seeing in commercial refrigeration at this point. And the last reason why we decided to head towards natural refrigerants, even with the small charge of 5.3 ounces, most light commercial applications could already be covered with that small charge. Compressor changes. In this section, we're going to take a look at a few of the things that are different and also kind of focus on the things that are the same. We'll take a look at the compressor and also the entire system, see what has changed in these systems. This first slide is looking at the compressor displacement. And here we're looking at a medium temperature application. And you can see that R290 is usually a bit bigger compared to R404, but smaller compared to R134. And as I switch to the next slide, the only thing that's going to change is we're going to look at a low temperature application, and the percentages will change a little bit there. But otherwise, R290 is still right in between R404A and R134A. So what this means for the actual compressor itself is that the external dimensions are normally the same. It's going to look pretty much the same as your R134A or your 404A compressor would. Next here, we'll take a look at the operating pressures. Also, again, very similar to those R404A and R134A questions systems. And so R290 is going to be right in between. It's going to be lower than R404A, but higher than R134A. So still very similar to what you're used to seeing out in the field. This is where we're going to start to see some differences here. So when we look at these IEC standards, that's that regulatory body, the worldwide level that I just mentioned previously. So here, this is the standards that have the 5.3 ounces that we can have in these systems. But most importantly for this presentation is going to be these right here that we're looking at for the explosive atmospheres and electrical apparatus for explosive gas atmospheres. And this is going to have to do with the construction and testing and marking of the electrical components that's used in explosive atmospheres. And the next slide illustrates this best. On the screen here, on the right-hand side, we're looking at a Clixon or a 3/4 round overload protector that you might find in one of our R134A compressors, for instance. And now if you look on the left-hand side of the screen, you're going to look at that same overload that's going to be found on our R290 compressor. And the big difference there is it just has to be sealed up. Everything has to be explosion proof, and it's got to be sealed so that you can't possibly produce a spark inside that system in case there were to be a leak and you were to have some R290 in the area of that component. So when you look at these electrical components, you can see that we had to redesign that overload. But then if you look at the type in the middle, the 4TM type, it was already sealed and just had to be proven to be sealed and explosion proof. So you never really know for sure with a certain electrical component whether or not it would have worked or if they needed an all new design for these. which is very important for our systems and very important for aftermarket in particular, because we're always going to want to use electrical components that are explosion proof or specifically designed for these systems, just to make sure that we have something that is going to go into the system and not potentially cause a spark in an atmosphere where there's a flammable mixture of R290 or R600A. Looking at the whole system here, one of the big changes that you'll see is right here, this first one, this caution risk of fire R290 label. You're going to see that on the compressor. And here in the US, it's also an EPA requirement that the process tube have a red sleeve. So as a technician walks up to one of these cabinets and takes a look, they should immediately be able to see this sticker and that red sleeve on the process tube and identify that that cabinet is going to have a flammable refrigerant inside. Otherwise, for the condenser, it's going to be very similar, maybe slightly smaller to account for the smaller refrigerant charge. The evaporator is going to be pretty much the same, as is the piping and the filter dryer. Well, you just want to make sure that you have an R290 compatible filter dryer. The capillary tube is going to be pretty much the same. It might be slightly longer. It's when you get down to things like the expansion valves and then fan motors, which need to be spark free, and fan blades that need to be non-spark producing, like plastic or aluminum, and those other electrical components that have to be approved per that IEC standard to be in an explosive atmosphere. And that's really where you're going to start to see the difference in these systems compared to what we've seen previously with our more traditional, if you will, refrigerants. Looking at the lubricants, R290 is totally miscible with POE, mineral, and alkylbenzene oils. I know from Embraco, you will see alkylbenzene and POE oil being used. I believe we've pretty much gone away from using alkylbenzene and only use POE at this point, but you will see them both out there. So just a note, when you're working on one of these, you'll always want to look at the label plate or pull out the compressor spec sheet or something to see what kind of oil is in that system. Safety and practical, probably the most important segment of this presentation. One of the biggest things you can do is just use common sense and stay alert when working on these systems, just knowing that there's a flammable component involved and how you would act differently because of that flammable component to how you may when working with a normal system that doesn't have a flammable refrigerant inside, something that you're used to working with. Probably one of the biggest recommendations that we can make is to develop a work procedure that keeps in mind the flammable nature of the natural refrigerants, but follow that on every job, not just a job that definitely has a natural refrigerant inside. And I say that for a couple reasons here. If you look at the third bullet, hydrocarbon refrigerants do not have an odorant, so you can't walk up to that cabinet and identify a leak by smell. These refrigerants, and we'll discuss this a bit later as well, they're very, very pure, so they don't have room inside there to have the sulfur, to have that odorant. So not being able to identify it is one important thing by smell. And then if you look at the last bullet, every time I do this training presentation, I'm always asked by everyone about incidents out there. Has anyone gotten hurt? Has anyone blown anything up? They always want to know these kind of incident reports. And if you go looking for incident reports, you don't typically find stuff where a technician walked up to a job site and they identified an R290 cabinet. They saw that it had a sticker on there to identify that flammable refrigerant, or maybe they saw the red process tube. They knew that it was in there, and then they still got hurt. What you will find a lot of is an illegal refrigerant that has a flammable component, or one of these blends, as we start to have more and more different refrigerants developed as we work towards pushing this GWP down, and it has a flammable mix component to it. Or something where someone actually took just a fully flammable refrigerant like R290, but put it into a cabinet where it's not designed to be. Those are the ones that you'll find a lot of, those types of incident reports. And so that's why we ask that in these work procedures, you might have your first step be that you showed up to your job site and you pull out your combustible gas detector and you check on the outside of the cabinet and then check the inside of the cabinet and just check your entire workspace. Even if you don't think that cabinet should have a flammable refrigerant in it, just make sure. It's a very quick check. It's only going to take you a minute. But it should just be something that you just start to do with every job, because there is so much equipment out there these days that has flammable refrigerant or a refrigerant with a flammable component that's in it. So that's what we want to see in those work procedures, is things that you can add some little safety checks and basic items like that that can help keep you safe on every job. So now we're looking at a flammability threshold chart. This is another very important one, kind of right along there with the work procedure. So R290 and R600A can't just be explosive or flammable. They do have to be in a flammable mixture, and you have to have the right atmospheric conditions. So we're going to stick to the R290 portion on the right-hand side of the screen. And if we look there at the lower explosion limit of 2.1%, so what it's trying to tell us is that 2.1% is the atmospheric requirement, how much we need in our atmosphere for it to be flammable. Maybe the easiest way to think about this, going forward, just make a note. R290 and R600A are heavier than air, so they will tend to drop and go down to the floor or into the bottom of the cabinet or wherever they are. But to try to illustrate this, let's just try to picture the room that we're in. If you could seal off the room that you're in and make it airtight, and you could pump R290 in there and have it be equally distributed throughout your room, not cooled at the bottom, but it's all equal throughout your space and your atmosphere, and it's only 1%. You're not going to have enough R290 in your space for it to be flammable. And on the opposite side of that, if you could seal off your room and you could pump it full of R290, and now you're at 12% R290 in your space, you have too much R290 for it to be flammable. So what you need to have a flammable mixture is to have that component in your atmosphere fall somewhere between 2.1 and 9.5%. And this is important because of the example room dimensions on the right-hand side of the screen here. So I know it's in meters, so I will translate that for you as best I can. Those room dimensions, if you could picture a space that's 6 feet tall, 5 feet deep, and 5 feet wide. So basically a space that is kind of me by me by me. If you can picture a space that's the size of yourself, basically, it would be a very strange space in the first place, pretty small, not a normal sized room. And if you took a cabinet that had the entire max charge of 5.3 ounces and you leaked it into that space, you would end up at around 1.85% atmosphere if you had it equally distributed through that space. So that full max charge isn't going to give you enough in that small space to get a flammable mixture. So to drive that percentage up so that it falls between 2.1 and 9.5%, you're going to want to shrink down the size of your space. So as you do that and you get a little bit smaller and smaller, and so you're driving the percentage portion up, you're probably going to end up with something about the size of your cabinet. And so we say that the cabinet is probably one of the more dangerous potential places, at least, to make a flammable mixture of gas, because it has the right size based on the charges that we have in these systems that you could produce a flammable mix inside that cabinet. And now thinking about it as a tech here in the aftermarket, this may or may not be something that is going to present a danger as you work on a cabinet. You may walk up to a job, and if there was a catastrophic leak and all the charge leaked inside the cabinet, you may, the whole charge is in there. Hopefully the equipment has shut down on some sort of safety, and all of the R290 is probably settled down into the bottom. And so when you get there, you do your checks on the outside, you do your check on the inside, you find the R290 and you open the door, you get some ventilation going, and hopefully that R290 is just gone and it dissipates into the environment. However, thinking back to those electrical components, if someone had come along and worked on that cabinet and they installed a fan that wasn't a spark-proof fan and it didn't have the plastic or aluminum blades on it, and then you had that leak, that's when you really have a potential for a possible explosion on that job site, is right when that leak happens. So definitely hoping there to just kind of drive home the idea that those electrical components are very, very important for us in the aftermarket. We may have to think about them a little bit more than we're used to when it comes to those replacements. And then also just where to watch on your job site. It's the best potential for a flammable mixture. So we also want you to conduct a risk assessment at every job site to see if it is appropriate to be working on a flammable refrigerant in that space. The second bullet there, I always get some funny looks when I mention this, but we want you to look around and find an area that is free from sources of ignition, open flames, sparking electrical devices like light switches, things like that. And we want you to have a 10-foot radius around a piece of equipment that you're servicing. I know that they don't design commercial kitchens so that you can have a 10-foot radius around every piece of equipment in there, and that's not always reasonable. But that is the goal, is to try to create an area around your workspace. And of course, and especially if you can't get 10 feet, have a fan that is providing ventilation across your workspace. As we mentioned, it's a very small charge that's inside these systems. And if you have that fan blowing across and you do have a leak, that R290 is going to disappear into your environment very quickly. And of course, we always want you to wear PPE when you're working on these systems. Again, here, the second bullet, you'll see that combustible gas detector. You'll hear that a lot. Same with the ventilation here, the third bullet. And with that combustible gas detector, we do want it to be the first thing that you do. Check the outside of the cabinet, check the inside of the cabinet. But then we also want you to just leave it running at a low level, because that R290 or R600A, whichever, is heavier than air. Just leave it running on the ground right in front of your work site, and then you'll know if there's any sort of leak that needs your attention during the progress of your maintenance. And as far as this fan goes here, for those of you that have read the little thing about the explosive atmospheres and having your fan rated for that, that's probably a very nice fan, and that is obviously the ideal, is to have all of your equipment when you're working on these systems be rated for explosive atmospheres. But if you can't do that with your fan, or you can't find that fan, we still definitely want you to have a fan on the job site. Just put it further than 10 feet away from your equipment, but just still make sure that you're getting a good airflow across your job site. And that really goes, as I mentioned previously on the last slide there, with all the tools. We want you to have vacuum pumps that are rated for working with R290, and spark-proof tools, and anti-static electricity tags, all these different kinds of pieces of equipment that are safe for working on with these gases. And that, of course, includes the recovery machine as well. One of the big advantages to these refrigerants is that you do not have to recover. So you may or may not find yourself with a certain situation or a job site that just requires it because of the risk, or a certain customer that requires you to recover instead of ventilating, instead of venting. And if you can vent, great. If you can't because of one of those requirements, then we do want you to use this recovery machine specifically designed for hydrocarbons, because your current recovery machine is going to have sources of ignition on it, such as switches and pressure controls and relays. Also, with the recovery cylinders, you can see here the pressure ratings and the compatibility of valve seals, how much you can fill them up. We want you to have recovery cylinders that are specific to R290. So just to kind of reiterate what we looked at before, for the replacement of an electrical part, we would want you to go to the job site. First thing you do is you sweep the work site with your hydrocarbon gas detector. Check the work site, check the inside of the cabinet. Leave the doors open, especially if you found anything in there, get some ventilation going. And then disconnect the main electrical supply. And then for right now, we have on here, replace failed components using original equipment parts. And the reason that we say to use the OEM parts right now is there just isn't a whole lot when it comes to replacement parts like the thermostats, for instance, or a lot of these different components that we're used to buying in the aftermarket that are yet rated here in the United States for R290 or R600A use. And so our recommendation is, unless you know that you can get one at your local wholesaler, is that for now you go back to the OEM until those things are more readily available. So again, just to go back over it one more time with the general precautions, the inside of the cabinet is definitely your best likelihood of forming a flammable mixture of R290 on your job site. However, you just never know with the external portion of the cabinet, a built-in system or whatever's going on with the airflow. We always want you to also consider the possibility that a flammable mixture could develop external to the cabinet, and that's why we want you to leave your combustible gas detector running the entire time that you're working. So I'm not going to hit these next 3 slides in full detail. You can take a look and read them here as I just briefly discuss. Really what we're trying to say with these slides is that when you're taking all these safety precautions and putting this little extra bit into your job and you're working on this specific system, if the compressor has failed, we definitely want you to continue to do an entire refrigeration circuit check and really try to figure out what caused that compressor to fail, if something caused it to fail, and to make sure that it did in fact fail and that it's not something like an internal overload that's not resetting or something like that. And so very, very important when you're working on these. We just would not want you to have to get callbacks and go back out and rework on one of these systems when it's something else inside that system that's causing the compressor to fail. So that's what these 3 slides are about right here. And we've made it to our next polling question before we get into the compressor replacement. Have you used the Embraco Toolbox app to access Spec Sheet? And that's just an easy yes or no. Looks like we've got a few more coming in here. All right, we'll go ahead. So it looks like only a few have. I definitely recommend taking a look at it. If you find yourself working on Embraco compressors much, all of the information is available on the Toolbox app, and you'll be able to get the spec sheets and see all of the different. In fact, actually, I'll just stop and move the slide forward and show you a spec sheet here. So the compressor replacement. Here's that spec sheet I was talking about. If you look on the right-hand side of the screen, this is what the spec sheet's going to look like. And so you're going to have things, the process tube and the suction and discharge tube are going to be identified, and you'll have your electrical diagram, and you'll get information about the winding resistances and the voltage ratings and the amp ratings and different specs on the components and things like that. So definitely useful to help you troubleshoot that system and to troubleshoot that compressor, and then just make sure that everything is squared away and you have the right compressor when you are making a replacement. So as you get in to make that compressor replacement, you've probably seen, I think we mentioned 2 of the 3 things here. Definitely that combustible gas detector, very, very important for the job site. And just to do your pre-check and then also leave it running the entire time that you're working in a low area. Again, with the fan and providing ventilation across the work site. And then the one that we haven't mentioned, posting a safety placard or a safety sign, just so that other people around your job site know that there could be a flammable refrigerant in that space. So I'm not going to hit every bullet on here since it's a bit outside the scope, but what I will hit is some of the stuff that we want to look for that may be a bit different to how you're used to doing a compressor replacement. So number 2 here, ground the cabinet if possible, just another thing to help try to avoid sparking. Number 3, we also recommend that you vent from the high side and the low side in case there's any sort of a clog in the cap tube or the filter dryer. You really want to make sure that you can get all of that R290 out. And then, of course, number 4 and 5 down here, the big difference is being able to vent the refrigerant instead of having to recover. And so the big thing there is just that risk assessment of your job site and making sure that you're in a safe place that you can vent. One other thing that we see a bunch is if you can't vent right in that spot, is running a hose from the equipment out a door or out a window or something like that, and do the venting that way, and then just use your combustible gas detector to check at the end of the hose to see when you're done venting. And as we discussed before, if you cannot vent, oops, I'm going too fast on the slide there. Let me let that recover. If you cannot vent, then we want you to use that hydrocarbon-specific recovery machine and recovery cylinders, just to make sure that you have the right cylinders, the right seal compatibility, that you don't have any of those potentially spark-producing switches or relays or anything like that on your equipment. For the actual compressor removal, we want you to try to cut the tubes with a tubing cutter. But the big thing that you'll notice on here is if you do have to unbraze, we have an initial 50-pound nitrogen purge, and then we have the cutting of the tubes, we have unbrazing, and if you have to unbraze, we want you to do another 50-pound nitrogen purge, and then of course to purge at 1 to 2 pounds while you are brazing to displace any residual hydrocarbons in that system. So really the big thing we're trying to stress here is that we just really want you to get all of the hydrocarbon out of that system, but especially if you're going to be brazing on the system. For the installation of the new compressor, again with the nitrogen purge at 1 to 2 pounds while you're brazing. And then probably the big thing on this screen is down here at number 4, installing the new filter dryer and just making sure that your filter dryer is going to be compatible with R290. The big one on this slide is going to be number 7. Always use refrigerant that is labeled R290 and not just propane. So for this one, unfortunately, the blue Rhino that you are using on your back deck and got at the local grocery store is not going to be good for this refrigeration system. And we definitely want to use something that's labeled R290. R290 is extremely pure. Refrigerant grade R290 that we're using in these systems is around 99.5, 99% pure. And then there's even going to be guidance as to what the leftover can be. That's why we can't have an odorant in these. And it's also not going to have moisture and other things like that that are bad for your refrigeration system, which is why we always want to make sure that we use something labeled R290. This little bullet on the right-hand side, if you have a 1% degradation in the purity of your R290, it could lead to a 3 to 6% degradation in your system performance. So you can see how using something that's not recommended for that system, in addition to having moisture and other things in it that aren't good for your refrigeration system, it's also just not going to perform well. So this is just something else that can prevent you from getting called back out. The big gray box in the middle of the screen has a couple other tips that we can look at. These are things that are definitely not required or mandatory, but just that we recommend to try to help you get the best and most accurate charge into that system and prevent having to go back out and do rework on a system. We recommend weighing in the charge using the label on the cabinet. Just try to be as precise as possible because it's a very, very small charge. 5.3 ounces is your maximum charge. Your system that you're working on may have 1.9 ounces in there. And you really, really need to be accurate when you have a small charge like that, which is why we recommend weighing it in. Also, it mentions there the service hoses. You've probably seen the 12-inch and 18-inch service hoses these days out there in the wholesalers, and they have a 2-millimeter ID, very, very narrow hoses. Just something to keep you, if you have a 6-foot hose and you have a 1.9 ounce charge, you can lose the entire charge in there. And so just some little changes you may make like that to help be accurate and get the best charge in that system. And then finally, we also want you to remember to meter the rest of the charge from the charging and the high side hose to the low side as you get the system going here. In the gray box down here is one interesting point where if you go and you search for some of the other literature that's out there on R290 and working on it, you'll find plenty of OEMs and other companies besides Embraco that have PDFs and videos and other things out there that you can watch. And what you'll typically see on those is when they go to seal up the system, they will seal off the process tube with brazing. And so there's always the question when people see the video that I typically show, you'll see it on the next slide, or the link to it at least. They ask, did they braze on the system when there's R290 in it after it's been charged? And the answer is yes, that they did, because you want to seal the system. But a few months back, we had some of the UL guys and some OEM guys down in our office, and they recommended looking at something like the lock ring system. And so what the lock ring system is it allows you to install that compressor without having to braze. And this may just be something that as we start to get more and more equipment that's falling outside of the manufacturer's warranty, things are starting to be worked on more, just more R290 equipment out there in general, that these guys at this level are wanting to remove that potential error point or give people options if they're uncomfortable brazing when there is R290 inside that system. And so that's something you can look at as one of these no braze systems to install your compressor. The big note that I would say with those is we did have to put out a white paper with those. It has a little compound or glue or sealant, and you want to make sure you get the right amount on there and not overdo with that system. And so if you are choosing to use something like that and not braze, my request is just to follow the instructions with it as closely as possible and really try and just get the best installation by following those. So I'll leave this last slide up here for a minute. Usually at this portion of the training, I would show a video, and you can click on the link there if you would like, and it will bring it up and then just save it for in a couple minutes. But it's a video of an R290 compressor changeout. And this was done in our factory down in Brazil. And so I would challenge you to do a couple things when you're watching that video. When it was done, this was several years back, and it wasn't made specifically for the United States. They're in our factory, and they know their conditions, and they know the ventilation, and they know what they're working on, and all these different things that we just talked about on how to stay safe working on these systems. So they don't include all those things in the video. It's still very good with all of its technical information, so I highly encourage you to watch it. However, I would also challenge you to be thinking about all the things that we just talked about that are going to help you stay safe when you're working on one of these refrigeration systems. Things like using the combustible gas detector, using that fan for ventilation, having a work procedure developed that you use on every job, those kind of things, and watch what they're doing in there and try and incorporate that into the video. And with that, we have reached the end and time for some questions. So I'm going to hand it back over to Kyle.
Thank you very much, Matt. That was a great presentation. Like you said, we do have a few minutes for the speaker to address some of the questions that you guys have submitted throughout the program here. First one up is from Bob Feathers. What trends in failure are different with R290, if there are any?
So at this point, I don't have any hard data based on numbers that have come back into our office. So it's only based on what I'm hearing as I travel around, and I have not been able to find a trend really with that. But I would, if we will have the email addresses for everyone that asks questions, that's something I can look up back at the office and see if there's something that we see on the commercial side from those guys in that segment that maybe I could put out just as a awareness thing.
Okay, sounds good. Next one here is from Bill. Are the contractors required to take a course or get a license to use these gases?
So as of right now, they are not. And this is one of the reasons why I very much stress doing that like refrigeration class or refrigerant class, and also just staying as up to date as you possibly can with continued training, because I have seen that there's a training requirement that could potentially be involved in the bill that Congress is looking at when they're looking at this, allowing the EPA to go through with some of these bans. Now, that may be for A2Ls where I've specifically seen it, and that isn't R290 and R600A, but it could also be for the A3 gases. So as of right now, there is nothing. It's all voluntary training that guys are taking just to try to feel safe when they're working on these systems. However, there is nothing that says that they have to be certified, but it could be coming. So something to definitely watch out for.
Okay, good to know. Next one up here is Marshall. What BTU can be achieved with a 5.3 ounce charge in the medium temperature range?
That's a good question. I don't have that info off the top of my head, but what I can tell you is that in our aftermarket portfolio at Embraco, we have a 1.25 horsepower medium back pressure R290 compressor. And so they've been able to get it up reasonably high. I don't have the BTU specifically off the top of my head, but I could look that up and send that info out as well.
All right. Sounds like you have a lot of homework after this thing.
I do.
Next one up here. Do you recommend using braze-free tools for servicing flammable small appliances?
I would have to say yes, that I do. And that's because of the recommendations from the UL and the OEMs that came into our office. And It's just what the information that they're putting out, and it's how they want to see it done. But that being said, it really depends on your personal level of comfort. As I travel around and I put that information out, really everyone that I talk to that's worked on these systems has just been brazing on the systems. And so there's a lot of people that feel comfortable doing that, don't have a problem with it at all. So I think it just comes down to the individual.
All right, next question up here is from Timothy. I've been doing some research on automotive R1234YF. Will that be a refrigerant we might need info on?
It could be. It's one of those A2Ls, and so it does definitely fall into the flammable category, just not quite as maybe explosive or highly flammable as an R290 or R600A. The feedback that I've gotten when it comes to commercial refrigeration, light commercial refrigeration, is that the A2Ls tend to be very hot. And so that's why we've kind of avoided using those in our systems. And what you would see is based on those original slides that we looked at, you see a lot of stuff where we're saying, okay, you can use 513 and you can use 450 and 452 and 448 and 449, some of those A1 that I called interim refrigerants earlier. Those are all being approved for use in our current R134A and 404A compressors. And then we kind of jumped right to R290 and R600A and skipped over a lot of those A2Ls, and that's because of that temperature factor. But that doesn't mean that we won't be using those in the future. But I do know for 1234YF, as of right now, I believe 80% of new cars that come out have that refrigerant in it. So it's definitely something that's out there, and it's out there in large quantities.
Okay, next question here from Benjamin. When you say R290 doesn't have room for sulfur, what do you mean by that?
So specifically what I mean is that when it comes to that purity requirement and how we want to use something labeled R290 and not labeled, Blue Rhino or whatever it may be that you buy to use on your propane grill, that R290 specifically is very, very pure. It can be 99.5% pure. And so to be that pure, you don't have enough left over that isn't R290 in that cylinder that you can have an odorant. There will be the tiniest little bit of sulfur in there likely, but not enough to be an official odorant or anything that's going to be in enough quantity that you can smell, because that would drive the purity down so much that it wouldn't be nearly as functional in your refrigeration system.
All right, next one here, Mike. If you're changing out a component in a I'll try this again. If you're changing out a component in a circuit and all the freon is recovered, how do you prevent flash off with your torch of freon trapped in the oil?
That's a good question. I haven't actually heard much about that incident or that problem. I'll get back to you on that one. That'll be a homework one. I'll get with our tech specialist and find out any specifics that we're looking for with an R290 system.
Okay. Next one up here, Todd. Are they making a recovery for R290 now?
Yes. So I've started to see it as I travel around to wholesalers across the country. I've seen both a recovery unit and a vacuum pump at this point, in addition to countless manifolds and small little charging hoses and things like that. There's getting to be a lot of equipment available out there, but it is taking its time coming over from Europe. The good thing is that this stuff has been available and used in Europe, and a lot of our major manufacturers that we have over here already have this equipment. They just haven't had a need for it over here yet. So it's starting to get to that point that we're starting to work on these systems more and more. Those manufacturers are bringing their equipment over here to the U.S. And so if you don't see it when you go to a store, if you need it, they can likely get it if you ask for it.
All right, and we're going to squeeze this last one in here. We've been very generous with your time. We appreciate it. What is the process for changing lubricant?
So really, for one of these, it's going to be the same as it might be for R134A or any other system that you're working on. If there's POE in that system, you should be able to, because you're not, I guess the big thing with these is you're not going to go, I'm not sure if I 100% understand the question, but you're not going to be able to retrofit an older cabinet with R290. So if you had an R134A cabinet, for instance, you couldn't put R290 in there because none of the electrical components and airflows and just everything about the engineering of that system is designed for a flammable gas. And so any system that you're working on is going to be an R290 system that has R290 in it. It's going to have been designed for that flammable refrigerant. And so I don't really see a need for like a full change out when you're maybe switching compressors and refrigerants and then going to a different oil or anything like that. So I would say that it would just be your standard where we would want you to pour the oil out of the compressors. You're doing a compressor change to make sure that you're within about 2% of the total quantity of that oil, and really make sure that you just have that whole system cleared out as best as possible. And if you're not, then to flush the system before you put the new compressor in.
All right, sounds good. And I lied to you here, Matt, because I have one more question actually I want to get in that popped up that I found interesting. So if you have time for one more, what percentage of OEMs that you work with today are actively making changes to their equipment to accommodate the R290 refrigerant?
I can't give you an exact percentage, unfortunately, because I am on the aftermarket side and not in our commercial segment. However, I can say that it started with True. Really, they weren't the first, but they were the first and biggest adopter, and they were back about 2014. And so a lot of the big, especially the nationwide OEMs, where they're sending stuff to every state, and they're not regional, and they can't kind of dodge these bans and these laws that have been put in place. All those big guys have already kind of changed over, and they're using R290 and in very, very large numbers. And so there is a very large amount of this equipment out there, and just more to come. So it's definitely something that I recommend. Not trying to dodge it, because it's just going to eventually be the majority of the equipment as time goes on.
Right, I gotcha. That's all the time we have for questions today, although important to point out, in addition to the homework that we gave Matt on a few of those questions, they've been kind enough to say any questions that were asked will be addressed via email in a follow-up. So if you did ask a question, you will get it answered. Please join me in thanking Matt Sopp for his presentation, and of course our sponsor, Umbraco Nedick. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. As you exit today's webinar, please take a couple minutes to complete our survey. We strongly welcome your detailed comments. You can visit achrnews.com/webinars for the archive of this presentation, as well as information about our upcoming events. We appreciate the time and hope you found this webinar to be a valuable experience. Enjoy the remainder of your day.